over the online homework a couple of the problems folks were having trouble with. So I wanted to go over those. So up till now, we've only done one-dimensional kinematics problems. But you can make those kind of interesting by combining two problems into one. An example is a car is accelerating to get onto the freeway. So as long as there's constant acceleration, we can use kinematics equations. So if the car is accelerating to get onto the freeway, their speed's increasing for a certain amount of time, constant acceleration, and then maybe they're going up above the speed limit, and then they see the highway patrol car and they start to slow down with constant acceleration, but different than the acceleration when they were speeding up. Okay, so they had one constant acceleration for this time period, then they had another constant acceleration for the second time period. So you can't go from the beginning to the end with kinematics equations because the acceleration is not constant over that whole time interval. It changed in the middle somewhere. But you can go up to that point where it changed with kinematics equations and find out how fast the car was going at its maximum, right, when it changed its acceleration. You can find out how long that took. Then those parameters become your initial values for the next problem, and you can use the constant acceleration for that window, but you can't go from the beginning to the end. Does that make sense? So you have it's going to start from rest. And it's going to go with constant acceleration. And let's just say we could do a certain amount of time, maybe. This could be 5 meters per second squared, and the time, how about 7 seconds? Okay, so the car is speeding up to get onto the highway. Then at this time, after 7 seconds, they spot the highway patrol car, and then they so how about minus 3 meters per second squared, something like that, and then what are we looking for? How long it takes to get to the speed limit, something like that. Okay, something like that. The car starts out, accelerates. Pretty soon it's going above 20 meters per second. Then it accelerates at a different rate, this time slowing down for a certain amount of time until it gets to the speed limit. All right, so how would we do this problem? So you basically have to split this up into problem 1 and problem 2. And the reason you have to do that is that our kinematics equations only work when we have constant acceleration. And it's constant for the first 7 seconds, and it's constant after that, but it changes in the middle, right? You can't go from the beginning to the end. It's 5 at one point, it's minus 3 at another point. You can't go from the beginning to the end. It's not constant from the beginning to the end. All right, so what I would do, make up my chart here. So this is first part. and this is the second part. So if we're starting here at x equals 0, at some point, Gesundheit, the acceleration changes. So this is our first part, and this is our second part, right? The acceleration is going to change there. And we don't know what that is yet. So we can put in, we're going to start, let's say, at x equals 0. We don't know how far the car goes. Initial speed, 0. And we'll call that our positive direction, right? We don't know our final speed. Acceleration we know. And time we know, right? 7 seconds. So we know enough that we can solve for how far the distance was and what the final speed was. Now, in the second part, we don't know where it starts, where it stops. We don't know its initial speed. We don't know its final speed. We don't know much here, right? The only thing we know is, we do know final speed, 20 meters per second, and the acceleration minus 3 meters per second squared. So we don't have 3. If we knew 3 things in that chart, we could solve for the missing ones. We don't know 3. But these are linked together, these two charts, right? Because the final velocity on this side is equal to the initial velocity of the second part. You see that? So for the first part of the problem, the ending speed for the first part of the problem is our beginning speed for the second part of the problem. So we can use the information in the first part of the problem to solve for v final. And let's see, what would I do for that? Probably something that doesn't have an x in it, right? So that becomes your v initial for the second part, and then you have 3 things you can solve for the time it takes or the displacement. Okay. There's a video solution. If you go to the video solutions, there's a problem just like this on there. You can check that out. To do there, you have to go back to your definitions. Okay. So, what is average velocity? Is the change in x, right? It's the displacement over time. So if you know where you start and where you end, even if you move around, right? Even if your object moves this way, then it moves back, then it moves this way, then it moves back. If you know where you start and where you end, and you know how long that took, then you can find the average velocity, right?